Welcome to The Explainer. Today, we're going to put on our detective hats for a true crime-style investigation, but on a literal galactic scale. We aren't hunting for a missing person or some stolen artifact. No, we're looking at the Milky Way galaxy itself, investigating a massive, ancient structure that, well, it just doesn't belong. So it brings up a really fascinating question, right? How do you actually spot an alien star cluster hiding in our very own galaxy? I mean, the Milky Way is absolutely packed with billions of stars and over 100 globular clusters, and those are basically just these dense, spherical cities of ancient stars. Now, most of them were born right here. They share a common family history with us. But what if an extragalactic incomer managed to sneak in? What if it's masquerading as a local star cluster? How on earth would we even catch it?
Section 1, the suspect. Okay, let's dive into this. To solve any mystery, you obviously need a prime suspect first. Ours is a globular cluster known to astronomers as NGC 5694, or a bit more easily, Caldwell 66. Now, for decades, this just looked like another faint smudge of ancient stars in the night sky. But as researchers started looking a bit closer, the details just didn't add up. First off, it's incredibly far away. I'm talking a staggering distance of 114,100 light-years from us. That is way, way out in the extreme outer halo of the Milky Way, far beyond the bustling galactic center where we and most of our local stars hang out. The sheer, mind-boggling scale of that distance, that's our very first clue. Now, if you want to know exactly where to point your telescope tonight, you'll find our massive suspect hiding deep within the Hydra constellation. But even though it's kind of isolated out there in the dark, it's what this cluster is actively doing that really set off alarm bells for astronomers. There were some immediate, glaring red flags that made scientists suspicious of Caldwell 66's true origins. Just look at these anomalies. Not only is it extremely far away in the outer fringes of the halo, but it is moving unusually fast. It's clocking a radial velocity of negative 140 kilometers per second, which basically means it's hurtling straight toward us. And on top of that, its physical shape is just odd. It has this strange, extended structural profile. The way its outer density declines simply doesn't match the standard models we use for normal, classical globular clusters. Something is definitely off. Section 2, the forensic tool. So how exactly do you interrogate a ball of stars that's located over 100,000 light-years away? Well, you have to rely on the faint light emitted by the stars themselves. And this brings us to our primary forensic tool, chemical tagging. See, every star is made of gas, and that gas contains specific chemical elements forged by earlier generations of stars. By analyzing the exact elemental abundance pattern of a star cluster, we get something that acts exactly like a cosmic DNA fingerprint. Literally, this chemical tagging tells us the precise conditions of the exact environment where that cluster was originally born. Section 3, analyzing the evidence. With this forensic tool ready to go, a team of modern astrophysical detectives set out to analyze the evidence. First, they isolated 6 ancient, bright red giant stars right within Caldwell 66. Next, using the massive Very Large Telescope, the VLT down in Chile, they captured high-resolution spectra. Basically, they broke down that ancient starlight into a highly detailed rainbow. And finally, by measuring the dark gaps in that rainbow, which are known as atomic absorption lines, they could see exactly which chemical elements were present in the star's atmosphere. They were extracting the hidden DNA right out of the starlight. And this brilliantly illustrates the sheer precision behind their work. Notice how those data points align so beautifully, right horizontally across the zero line? The scientists didn't just trust one single method, they rigorously compared their initial iron abundance measurements against a totally different method called spectral synthesis. This proved there's virtually no systematic offset here. The hard science is incredibly robust. We can absolutely 100% trust these DNS test results. Section 4, the chemical anomaly. Now, what's really interesting about this slide is what happens when the lab results actually came back. The team immediately realized they were looking at something profoundly strange. Look at the glaring absences in this table. Barium, yttrium, and europium, severely depleted. Copper is remarkably deficient too. Now, these elements are created by very specific astrophysical processes, usually forged during the explosive deaths of massive stars. But in Caldwell 66, these absolutely crucial genetic markers are virtually missing. It's wild. To put that into perspective, imagine trying to bake a cake, but you completely leave out the sugar. Classical Milky Way clusters of a similar age have an expected baseline recipe of elements. They are rich in alpha and neutron capture elements. But our suspect, Caldwell 66, shows a totally different chemistry. Its basic building blocks, what astronomers call the alpha elements, do not match our galaxy's standard recipe at all, and its heavy elements are alarmingly low. So, the evidence is pretty conclusive. Caldwell 66 does not share Milky Way DNA. It literally could not have formed from the same massive gas clouds that birthed the rest of our galaxy's native star clusters. Which naturally leaves us with the ultimate question. If it didn't form here, where exactly did it come from? Section 5. The big reveal. So the crucial point is, the chemical signature of Caldwell 66 isn't just some random fluke. It perfectly matches a very specific type of environment. Its true origin is an entirely different galaxy, specifically a dwarf spheroidal galaxy. You see, dwarf galaxies have a much slower rate of star formation compared to massive galaxies like our Milky Way. And because they evolve slower, the chemical enrichment of their gas, which is driven by supernovas over millions of years, happens totally differently. This specific, slower nucleosynthesis perfectly explains the exact chemical deficiencies we see in Caldwell 66 today, like that glaring lack of barium and europium. This reveals an incredibly violent ancient history. Caldwell 66 was born in a distant dwarf galaxy billions of years ago. But over time, that smaller parent galaxy ventured just a bit too close to the Milky Way. Through the immense gravitational pull of our galaxy, the dwarf galaxy was literally torn apart. It was devoured. Its stars were scattered everywhere. But Caldwell 66, being this tightly bound massive cluster, managed to survive the carnage. It was left behind, stranded in our outer halo as an intact cosmic relic of a murdered galaxy. The researchers who published the study actually hit the nail on the head when they summarized the cluster's adopted status right in the title of their paper. They called NGC 5694 another foster son of the galactic halo. I mean, it's such a poignant reminder that not everything within our galactic borders was actually born here. The Milky Way has literally grown by absorbing its smaller neighbors, and Caldwell 66 is the undeniable, glowing proof of that cosmic cannibalism. As we close the case file on Caldwell 66, it really leaves us looking up at the night sky with an entirely new perspective. Think about it. If this one cluster managed to hide in the Hydra constellation for so long, perfectly masquerading as a local, it forces us to wonder, how many other alien star clusters are hiding right now in our night sky, just waiting for their true DNA to be discovered? Thank you so much for joining me on this explainer. And as always, keep your eyes on the stars.